So bridge planning, this is what we are discussing. So before planning any bridge, there will be few studies. First one is traffic studies, hydrotechnical studies. It relates to water. And next one, geotechnical studies. It relates to soil condition, environmental consideration. So definitely we have to go through at which location you are constructing these bridges. What are the environmental status nearby? Okay. So do you have any forestation? Do you have any forest area? Is that any kind of, environmental protecting area? So like that, environmental considerations are also very, very important before planning any bridge at a location. And alternatives for bridge type. Okay. So what are the alternatives for bridge type? So what type of, bridges will be suitable at that location? That also you have to plan, because there are different types of bridges. So in that, which type of bridge you are going to prefer at that location is very important. So that is the reason why you have to see the alternatives which are there to, consider a bridge at that particular location. And next one is economic feasibility. Economic feasibility, it always relates with the cost of the bridge. Okay. So again, when you choose a bridge, when you choose one type of bridge, so first you have to estimate, okay, whether that bridge is economical at that location or not. Okay. So that economic feasibility is very, very important before execution. Okay. And next one is bridge selection and detailed design. So what is that bridge selection and detailed design? So bridge selection in the sense, so as I told you, as you are having number of different bridges, so you have to select which type of bridge is suitable. So that's how you have to select the bridge, and detailed design you have to do, okay, before execution. Because without analyzing and without designing the bridge, you can't go for execution. Okay. So all these to be carried before execution or before planning any kind of bridge at a particular location. Okay. And see, yeah, so I think this also we discussed yesterday. So span, based on the span less than 6 meters, we are going to call it as a culverts. Greater than 6 meters, we are going to call it as a bridge. Okay. And the major bridges are having 3 different spans: short span, medium span, and long span. Okay. 6 to 30 meters, we call it as a short span bridges, right? So 30 to 100 meters, medium span bridges, and greater than 100 meters, long span bridges. Okay. Yeah. And next one is when you want to plan a bridge, so definitely it relates with the materials, it relates with the usage, and again span and structural form. Okay. So let's see the materials. With what materials you can construct a bridge, Amma? So you can construct a bridge with steel. You can construct a bridge with the timber. Okay. You can construct a bridge with concrete, and there will be hybrid bridges. Hybrid, and it will have steel and concrete. Okay. Nothing but composite underwater. Okay. Composite bridges are nothing but hybrid bridges. And you can even find stone bridges also. Okay. In olden days, the bridges are constructed with stones. Okay. Nothing but masonry bridges underwater. Okay. So stones in the sense masonry bridges. So like this, there are different materials where you can construct the bridges with them. And next one, usage. For what you are constructing the bridge? Are you constructing bridge for pedestrian walks only, for highways, or for railways? Okay, roadways. So like that, based on the usage also, the bridges are going to be classified. Okay. And next one, span. Again, span. Is your bridge a short span bridge, or long span bridge, or medium span bridge? Okay. So like that, based on the span also, your bridges are going to be classified. And next, structural form. Whether your bridge is a slab bridge, or whether your bridge is a girder bridge, or whether the bridge is a truss bridge, arch bridge, suspension bridge, cable stayed bridge. So like that, your bridge is going to be differentiated based on structural form. In which form that your bridge is. Okay. As slab ga unda, girder shape lo unda, truss bridge, cable stayed bridge, suspension bridge, arch bridge. Okay. So based on that also, bridges are going to be classified based on the structural form. Okay. If anyone asks you to decide a bridge for a particular location, you have to decide which material you have to use, which for what usage that bridge is supposed to be constructed, what kind of span you are preferring for, and next one, last one is structural form. What type of bridge is suitable for that particular location anedi chudali. Understand? So this is what about bridge considerations. And see, these are the materials and fabrications. Just now we have gone through like materials, masonry, timber, reinforced concrete, pre-stressed concrete, iron, steel, and composites. And coming to fabrication. So fabrication in the sense, one second. Yeah. Fabrication in the sense, there will be precast bridges. Precast will have a RCC and PC. And cast in place bridges, pre-tensioned bridges, post-tensioned bridges, prefabricated steel bridges, rivet steel bridges, bolted nothing but steel or timber bridges. Okay. So these are based on the fabrication, and these bridges based on the materials. Understand? So based on material and fabrication, the bridges can also be classified. Once again, sorry. Yeah, see highway bridges. So these are the examples of a few bridges in UK. Bristol Bridge kanivandi, lekapothe Avonmouth Bridge kanivandi. I think many of you know about Golden Gate Bridge, so which is a suspension bridge. Okay. And you know, pedestrian bridges. So these are the pedestrian bridges. Pedestrian bridges and it's only for pedestrian walk. It is not for vehicular passage anamata. Okay. So these are the pedestrian bridges which are located in UK. So even these bridges are also going to be constructed with the same kind of designs. Okay, but the purpose of the bridge is different. Okay. And next one, railway bridges. I think many of you know about railway bridges. Okay, so I think all railway bridges, I mean major railway bridges are made with steel. Okay, so this is the major steel railway bridge which is in Scotland, and this is which I am talking about, the stone bridge. Stone bridge is nothing but masonry arch bridges. Okay, so this is also for a railway, or sometimes it will be for roadways. Yeah. And see the based on structural form. So this is an arch bridge. Why? Because the bridge is in a form of an arch action. Okay. And this is a cable stayed bridge. So where the complete your bridge is suspended with the cables, right? And this is a steel bridge, truss bridge, steel and truss bridge. Okay. So which are connected with the rivets and all. Okay. So these are the different structural forms of the bridges. Yeah. Types of bridges. So you will have an arch bridge. So where arch bridges are one of the oldest types of bridge. So I think many of you know about the arch action. So what is the major advantage of an arch action? So arch action is having more advantage than the normal beam. Why? Because arch will have very less deflection. Okay. So because it is a counteraction to the beam deflection. If you take a longitudinal beam, when it bends, it will bend towards downward side. Okay. So adhe meeku emoutundi, arches will be reversal of the beam deflection. Okay. That's the reason why arches will have more load carrying capacity. Okay. So that is the reason why in olden days all bridges are made with an arch action. So arch bridges are one of the oldest types of bridges and have great natural strength. Okay, based on the shape itself, it will have more strength. Okay, that's why it is called natural strength under. Okay, and instead of pushing straight down, the weight of an arch bridge is carried outward along the curve of the arch to the supports at each end. That is what I am talking about. It will have the reversal, I mean, contraction to the beam bending. Okay, the arch shape itself. So at the same time, these supports called the abutments, because in arch we call that supports as an abutments, and where it will carry load and it keeps the ends of the bridge from spreading out. Okay, if you see the arch action, you can find it clearly, because in arch bridges you have seen clearly how the abutments, because for every arch bridges there will have only two abutments. Arches doesn't have any kind of piers in between. Okay, so that's why arch bridges will have only two abutments. Okay, where load will transfer from its crown to the abutments. Okay, I think you all studied arches in your strength of materials alone. I think you all familiar with that. Okay, and now see, the bridges are going to be classified based on a few things. First one, based upon type of structural arrangement. Okay, so based on arrangement, your bridges are going to be classified as an I girder bridge, plate girder bridge, truss girder bridge, suspension bridge. Okay, because this is one of the theoretical question which is very important. Based on the structural arrangement, what are the different types of bridges, and you have to list out all these. Okay, so these are the four bridges which are based on the structural arrangement: I girder bridge, plate girder bridge, truss girder bridge, and suspension bridge. Okay, and next one is based upon structural action or nature of structural superstructure action. Okay, so in the choosing the based on the arrangement. Now it is based on the structural action. So based on the structural action, bridges are classified into simply supported bridge, continuous bridge, cantilever bridge, arch bridge, rigid frame bridge. See, this is how you have to differentiate, and this is how do you have to separate all the bridges. Okay, based on the arrangement, based on the action. Okay, like that. See, again, see, based on the action, bridges are simply supported span bridge, continuous span bridge, cantilever bridge, arch bridge, rigid frame bridge. Okay, Namma? And next one, see, based on type of connections. Okay, so how you are connecting the bridge elements, how you are connecting foundation to pier, pier to girder, girder to slab. Based on the connections also, your bridges are going to be classified. Okay, in normal RCC, there won't be any kind of connection. Okay, so by the way, we should call RCC bridges are completely a rigid bridges anachu. Okay, so they are all RCC rigid bridges kabatti. If you come to connections in terms of steel, so definitely bridges are going to be connected with rivet. Bridges are going to be connected with welding. Steel bridges are going to be connected with the welding. They are going to be connected with the bolting. They are going to be connected with the pins. Okay, so by that, whenever the steel bridges are going to be connected, steel connections are going to be taken place in four different ways. Okay, so these are based on the connections. And next one, based upon floor action. What do you mean floor action? Floor action in the sense how that bridge is behaving based on the vehicular loading. Okay, until our deck on a type, based on the deck type also your bridge is going to be classified. So deck type bridges antaru, the through type bridge, and I will show you pictures somewhat, don't worry. For every type of bridge, I will show you the picture also. By that you can able to understand what is a deck type bridge, what is a through type bridge and all. Okay, deck type bridge and it will have only deck system. Through type bridge and through, where it will have both ends. Okay, through and one end to other end. Semi through type bridge or pony bridge under. Okay, and next one is double deck bridge used in rail cum road. Ante kada double deck bridges code untai. At bottom level there will be railways, and above the next level there will be roadways. So they are called a double deck bridges under. And these are all based on the floor action. So based on the floor action also your bridges are going to be classified. Okay, and next one, based upon movement of structural parts of the bridge. Why bridges will move? So definitely there will be bridges which are going to have some movement. Okay, If you see a bridge in Pumban Bridge in Rameshwaram, your bridge will open. Kada? So based on the movement also, your bridges are going to be classified. Okay, the best example is our Pumban Bridge, which is in Rameshwaram. So why that bridge will open? Why? Because there should be passage for the ships and all. So for that, definitely your bridge will have some movement. Okay, so based on the movement also, movement of the structural parts of the bridge, your bridges are going to be classified. Okay, so what are the different types of bridges based on the movement? Fixed or permanent bridge, movable bridge. So nothing but can open either horizontally or vertically, so as allow the river or channel traffic to pass. Okay, so few bridges will have movement. Few bridges will move either vertically or horizontally, because to have a traffic pass of the river or to have a traffic pass of the ships. Understand? So that's how bridges are going to be classified based on the movement. And next one, based upon the purpose of bridge. Okay, so purpose, for what you are constructing the bridge, for the roadway or for the railway or for the pedestrian walk, for what? So based on the purpose also, your bridges are going to be classified. And next one, based upon the loading. Okay, as I told you, along with the dead loads, there will be different live loads which will be considered in the bridges separately as IRC class AA loading, IRC class A loading, IRC class B loading, IRC class 70R loading. So like that, loadings will be differentiated. Based on the loadings also, your bridges are going to be classified. Why? Because A, B and Eventama, they're all depends on vehicular movement. Okay, based on the load. Okay, 70R loading will have around 70 tons of weight. So like that this class A, class B will differentiate the loadings on the bridges. Okay, so that's how based on the loadings also your bridges are going to be classified. Okay, and the next one is based upon the span. Okay, so please be careful. These are very, very important. Even when you come across a few competitive exams, so definitely they may ask you what is the culvert span. Okay, up to 6 meters of length. You can call a bridge as a culvert. You should not call it as a bridge. You should call it as a culvert. Okay, so any bridge which is having a span between 6 to 30 meters, we should call them as a minor bridge. Understand? So any span greater than 30 meters, we should call them as a major bridge. Okay, so please remember, any span less than 6 meters, we should call them as a culvert. Okay, pipe culvert avachu, box culverts avachu. It should call it as a culvert. And 6 to 30 meters, we should call them as a minor bridge. Over 30 meters, we should call them as a major bridge. Clear? Okay, so this is how the bridges are going to be classified based on the span length also. Okay, right. Now let's see each picture how the bridges are looking, looks like. So this is an arch bridge. As I told you, arch bridge will have only two ends, which are called as an abutments. Okay, so this is how arch, and this is how arch loading action. See, whenever load acts on the bridge, so this is a UDL load. With this UDL load will transfer to the abutments like this. You can make arrow mark converts in the black arrow mark. So this is how the load will transfer to the abutments, and the reactions will be from the horizontal and vertical reactions will be there at the abutments. Okay, and next one, masonry arch bridge. Okay, these are the oldest forms of bridges. Masonry arch bridge. This masonry arch bridges, nothing but they are constructed with the masonry stones. Okay, so this is the oldest bridges. So usually there are very superior to slab bridges, because as they are oldest bridges, so usually they can accommodate up to 3 to 15 meters of span also. Okay, and next one, beam bridge. Beam bridges enti, there will have only a beam which is supported with two supports. Ante. Understand? This is what a beam bridge. Beam bridge ante oka slab untundi and there will be two supports. This is how the bridge looks like. Okay. So as we all know, beam action ela untundamma, below the bottom fibers they are subjected to tension. Above the neutral axis, those fibers will be subjected to compression. This is what the beam action takes place. Kada? So these bridges are called beam bridges. See, example, this is how the beam bridge looks like. There will be piers and there will be slab on the top. And next one, pipe culvert. Okay, so me andaru culvert చూసుంటారు, but if anyone couldn't able to imagine, you can just see this. So these pipe culverts usually we usually constructed to have a water flow from one end to other end. Okay, so definitely this consists of pipe barrel under the embankment with the protection works at the entry and exit. Okay, so pipes untai. So why these pipes are going to be provided? To have a water passage from other one end to other end. Okay, so this is what I am talking about. These spans will be less than 6 meters only. Okay, so this is the span ante ekkadi nunchi ekkadi varaku amma. So from this end to this end. So this will be less than 6 meters. Okay, right? So this will have, these kind of bridges will have not only pipes, there will have even openings also like this. Openings also untai. Openings for what? Openings are for to have a vehicular passage. Okay, nenu in the first presentation lo chupichanu kada. So like that. So they will have a single cell culvert, double cell culvert, multiple cell culverts. So like that, culverts also will be provided with some vehicular passage also.
Hello, Nico. Can you move forward? You can also check why Nico moves talent in Talent House.
1 second. Okay, guys. So this is what about pipe culvert. See? So this is some river, or some, water flow. If you want to construct a bridge, okay, on the right hand side, you can see this is how the pipe culvert can be constructed. Okay, over this obstacle, right? And next one, slab bridge. Just now we have seen the slab bridge. Plate girder bridge. Plate girder, and it is completely a steel plate girder bridge. Okay, all these girders are made up of steel. So by the way, it is called the steel plate girder bridge. Truss bridge. See, truss bridge, and it is also made up of steel, but the bridge structure will be in a form of a truss. Okay, so usually truss bridges can accommodate long spans and matter. Okay, truss bridge. Suspension bridge. So this is what is suspension bridge. See, the whole deck, this whole deck is suspended with the strings, suspended with steel cables. Strings anachu, like the cables anachu. The whole deck is suspended with the steel cables. That's why it is called a suspension bridge. Okay, see how the forces transform from superstructure to substructure in the suspension bridges. Okay, one should know what are the action taking place in a suspension bridge. See, the vertical posts, we call the vertical members are called stanchions under. Okay, vertical member is always subjected to compression. Okay, and the suspenders, these are all called suspenders, vertical suspenders. All these suspenders are under tension. Each string will be subjected to tension. All these cable, cable jusara ila curve shape lo undi, ee cable also will be under tension. Okay, these columns, vertical posts are subjected to compression, and these cables are going to be anchored at the ends. Okay, these cables are going to be anchored at the ends. Okay, so one should know which member will be under tension and which members will be under compression in suspension bridges. Okay. Even anchoraging also will be under tension. And majorly in suspension bridges, major elements all will be under tension. Okay. Only vertical stanchions will be under compression. Like this. Okay. And next one, cable stayed bridge. See, you can see the difference between suspension bridge and cable stayed bridge. In this earlier, you can see the whole deck is suspended with the cables. Kada? Now in cable stayed bridge, you can see how the cables are. Every cable is connected to the deck, okay, with some spacing, and the whole deck is stayed in that position with the cables. That's why it is called a cable stayed bridge. Okay, cable stayed bridge. In our Hyderabad, the Durgam Cheru bridge is a cable stayed bridge. It is not a suspension bridge. Okay, it is a cable stayed bridge. Why? Because the whole deck is stayed with some cables. Okay, that's why it is called a cable stayed bridge. So this is an example of a cable stayed bridge. Next one, cantilever bridge. The best example of a cantilever bridge is our Pumban Bridge. Okay, so Pumban Bridge, why it is called a cantilever bridge? Because it is having an opening. Even our London Bridge, it is also a cantilever bridge. Why? Because London Bridge also will open at nights. London Bridge also will open whenever there is a traffic of ships and matter. Okay, so definitely, so any bridge which is having an opening, those bridges are a cantilever bridges. Okay, so
Your guess is as good as mine.
1 second. Like this. See the cantilever bridge here, you can see it clearly. This whole cantilever bridge is made up of steel with the made up of trusses. Okay, so this end is fixed and this end is free. Why it is called cantilever bridge? So this is the fixed end. Okay, and this is the end which is connected. This is the end which is free end. This is the fixed end. Understand? This is the free end. Okay, so and from this end to this end, there is a small, again there is a small truss which is provided. Okay, so this portion is called a cantilever portion. Is the cantilever portion because this is fixed and this end is free. Understand? So by that, this is called cantilever arm under the. Okay, that's why it is called cantilever arm. This is called anchor arm. And this center portion is called suspended span. Why? Because this span will have only a simply support. This span will have only a simply support. That's why it is called suspended span. This is called cantilever span. Understand? This is called cantilever bridge. Arch bridge మనం ఇందాకే చూసాం already. And the forces in the arch bridge will be like this. Movable bridge. Okay, this is what we just now spoke about. When a vehicle, when a shipping is moving in between the bridge, so definitely bridges will open, okay, to have a proper elevated height. Okay, so moving bridge is a bridge that moves, allow passage usually for boats or barges. Okay, so this is a live example. Okay, why how the bridges is opening to have a ship passage. So this is an example at canal. One second. Yeah, like this, all examples are here, Amma. So I will try. I will share this. What is that? This PPT. So by that you can also have a glance on this. Okay. Yeah, there is a small poll question. If anyone can answer this question, please answer. Which do you think is the greatest modern structure? Is it Eiffel Tower or Brooklyn Bridge or Switzerland's bridge or Burj Khalifa in Dubai? Which is the greatest modern structure? Which structure do you think is a modern structure? Guys, please respond. You can respond through chat box. You can respond through message or you can respond through voice also. Which one do you think as a modern structure, greatest modern structure? Guys, please respond. If anyone want to answer, you can unmute and you can answer. Which do you think is the greatest modern structure? Guys, ఏమా వినిపిస్తుందని నేను చెప్పేది? హలో హలో హలో
I think Burj Khalifa.
Okay, one answered as a Burj Khalifa. Okay, others? Others also please respond. Which one do you think as a modern structure out of all those four options?
Brooklyn Bridge, sir.
Brooklyn Bridge. Okay, others? Praveen got answer chesine Brooklyn Bridge ani.
Chandu, sir. Chandu.
Chandu, right. Chandu, why you answered Brooklyn Bridge as a modern structure? Because the Brooklyn Bridge was constructed in the year 1880s only, 1880. How can you think it is as a modern structure, greatest modern structure?
Sir, just guess చేసాను sir అంతే.
Guess చేసావు అంతేనా? No, actually your guess is right.
Yes, sir.
So that's why I'm asking why you told, why you answered that as a modern structure. See, out of four options, definitely Brooklyn Bridge is a greatest modern structure. Why? Because that is the oldest bridge which is still under existence and still under service. Okay, so we should consider them as a greatest modern structure. ఎందుకంటే అంటారు కదా old is gold అని, right? So any structure which is still under existence and still under service, so definitely we should consider them as a greatest modern structure, not structures which are constructed in recent years. Okay, so answer is a Brooklyn Bridge. So you can even Google search and see when it was constructed and what is the importance of that bridge. Okay, yeah, that's all, guys. In the next class, tomorrow also we are having class. So tomorrow we will discuss about types of loadings, and I will let you know what are the code books required for for designing this bridges based on IRC loadings and all. Okay, yeah. So for today's class, do you have any doubts, someone? So you can answer me. I will answer your questions. If you have any doubts, so please put your questions here. Anyone? Any doubts in the today's class? How to plan the bridge and what are the different types of bridges and choosam erosi. Okay. And how to consider the bridge also we have gone through. So any doubts in these topics? So please you can raise. No doubts? Em doubts in leva ఈరోజు క్లాస్ లో? Guys, if you respond, at least we can leave. Chepan, do you have any doubts in the today's class?
No, sir.
No?
No,
Others?
sir.
Others? Praveen, Panduranga, Raj, Abhishek.
No, sir.
Abhishek,
Nothing.
I think just now he
Not
joined.
yet,
I don't think he has a doubts. Huh?
Network issue, sir.
Yeah,
Network
yeah.
issue.
Okay, okay. No issue, no issue.
Yes.
If you have a network issue, for me, no issue.
And really, sir.
Oh, yeah, yeah. Abhishek, anyway, I got your attendance. Okay, don't worry.
Okay, thanks.
Okay, Akash Yadav. See, if you put your name along with your roll number, it will be easy for me to, call you up. Okay, then guys, see you in the next class. Okay, so please try to Google different types of bridges, have some questions. Okay, then I can able to answer them. Okay, in the tomorrow's class. Okay, right. See you guys.
థ్యాంక్ యూ సార్.
Hello. Chapter class lo